Hi there. Welcome, viewers and listeners. Today, another podcast of Studio Ab Ovo. Today with Edwin Visser,
Yes.
the managing director of, managing platform manager. What do we call you?
A platform development manager. So my role within Ab Ovo is I'm responsible for all our R&D developments and the continuous improvements of our development platform, the ecologic platform.
And today we're not talking just about the technical improvements, but also what it implies on sustainability.
Yes, at Ab Ovo we have a huge focus on sustainability and green IT as well. And today I actually wanted to talk about how IT in itself can be made greener, can be made more sustainable, but also to really reflect on where are the carbon emissions from IT actually coming from. So why is it that IT is contributing to the carbon emissions globally?
So beyond the obvious, actually. So not just what you see, but also flows behind.
Yeah, everything that flows behind. So there's it's a big chain, and in every step along the way, we create carbon.
Yes, of course. Yeah.
And when we look at the IT industry as in total, as a complete package, 2 years ago already, the carbon emissions from the IT sector, they were responsible for roughly 4% of all carbon emissions worldwide.
Wow.
Which puts them in the same league as the aviation industry.
Oh, really?
And with the advent of AI models and large language models, the ChatGPTs and the Claudes and the Mistrals, that number has obviously risen already in the last 2 years and is likely to rise even more in the coming years. So thinking about environmentally friendly software solutions is becoming more and more present. And that's why we at Ab Ovo are working on it.
Yes.
But I also wanted to just share some thoughts on it and where carbon is actually coming from the IT sector.
So not just the software, but also the hardware part, and even beyond that.
Yeah. So when we look at the carbon from the IT sector, obviously carbon comes from hardware. We have the big data centers, and we immediately get this image of the big data centers using up all the energy.
Yes.
But when we look at the carbon and the carbon emissions, where are they coming from? Actually, the first flow is before the server even hits a data center.
Okay.
Because when the server is manufactured, it has to be transported to the data center. And all of that also already creates carbon.
Yes.
This is what we call the embodied carbon of hardware.
Okay.
So embodied
in the hardware, yeah.
Yeah, in the hardware itself. So all the carbon emissions that are created during manufacturing and bringing a product to the market. And the carbon emissions are everywhere. This is not just servers. It's also in your phone. It's in your car. Every product has its own carbon footprint, just manufacturing.
Yes.
And depending on the product, the carbon emissions, the embodied carbon emissions, are actually higher than the usage carbon emissions.
Ah, okay.
So, for example, for the iPhone 14, roughly 80% of all carbon emissions throughout the lifespan of an iPhone 14, it was calculated, it emits roughly 12 kilograms of carbon equivalent.
Oh, wow.
And 80% of that is created during manufacturing, shipping, and bringing it to the customer. And only 20% of all the carbon emissions of an iPhone 14 come from using it.
Wow, so the physical part is a really important part.
The physical part is a really important part of the carbon emissions. And the same applies to IT, where we are building new data centers. We're running these AI programs on newer and newer chips, creating new carbon emissions. But we already have the surface built somewhere already. And actually prolonging the life of those servers. So if you use an iPhone 14 for 1 year longer, or use it twice as long, then suddenly the carbon emission of that phone reduces a lot because you're just using it a lot longer. So that's one stream of carbon emissions, and one way of improving or reducing the carbon footprint is by using your IT devices, your servers in your data center, but also your laptops, using it longer. Why after 4 years replace your employees' laptops with new laptops? Why not after 5 years?
But there's also like there's also where software development is coming in, because normally when me as a user, I need a larger laptop or a bigger phone because of the apps that are bigger, need more energy, need more calculations. So my old laptop doesn't work anymore. So when you of course, there is now software as a service when you can use stuff in the cloud.
Yeah.
That's also bringing the need for a bigger laptop or a laptop.
Now, if you use software in the cloud, it's basically run in a data center. So over time, you would need bigger data centers. But you can see already regulations and a call from the public for big manufacturers to allow for a longer life of products.
Yeah.
So when a new operating system is shipped, make sure that when you buy a new phone that you can use it for the next 7, 8, 10 years, and not that you have to buy a new phone just because you want to install the latest app after 5 years. And you see that happening already. So generally speaking, operating systems are supported for a longer time.
Okay.
But of course, the number of data centers, especially with all the cloud demand in the world, is growing.
Yeah.
And that's where we see also a huge increase in carbon emissions and from the usage of those data centers.
Okay.
And we look at where the data centers, where their carbon emissions are coming from, is actually because they use the CPU and the memory of that hardware. And in order to do that, they need energy in the form of electricity. And that energy is used for both running the computation on the chip, but it's also used to cool down your data center. Because running computations on your chip actually heats up the chip and you need to cool it down.
That's true, yeah.
And depending on whether a data center was built very efficiently or less efficient, you needed more energy for the cooling in regards to the amount of energy needed for running the computation, or you need less. And that can be covered in what it's called the power usage efficiency.
Is it like strange that you can better build some data center in Scandinavia is cheaper or less expensive than one in Africa?
Yeah, so in terms of cooling, based on that, you would need less cooling because the outside temperature is lower. But at the same time, you can also cool the data center, and perhaps in Africa you have more solar power. So if you can cool it in a green way, then the carbon emissions would still be lower. So there are a lot of different factors which are actually contributing to how much energy is needed to run the data center, and also how much carbon is then produced
by
for
that
running.
energy. By that energy.
So we have a power usage efficiency, which is the PUE.
Okay.
It is a label that can be put on data centers, and a very efficient data center has a good PUE, whereas a less efficient data center has a lower PUE.
Okay.
In general. So, and that's just whether and how much energy they need.
Yeah.
But then, of course, like the example with Africa, it also depends where your data center is built.
Yeah.
So 2 data centers using the same amount of energy, depending on how that energy is created, it can still be very polluting or more green. If you have lots of solar energy available or wind energy, you might use a lot of energy, but it's emitting less carbon.
It's just more sustainable.
It's more sustainable. And the amount of carbon per kilowatt hour that is needed to run that same kilowatt hour, that's called the carbon intensity. And we have different carbon intensity numbers on average per country. So for example, countries like Norway, they have a very low carbon intensity. They have roughly 27 grams of carbon equivalent per kilowatt hour.
Okay, yeah.
Whereas the Netherlands, surprisingly, is actually, if we look at Europe, a lot less or has a very high carbon intensity, especially compared to Norway.
Okay.
So it's 261 grams of kilowatt of, it is 280 grams of carbon equivalent per kilowatt hour in the Netherlands.
It's 10 times more.
It's almost 10 times more.
Wow.
So just by choosing a data center or choosing where you're running your application in the Netherlands or in Norway already increases your carbon footprint of your software tenfold.
So in like in the Netherlands, they are not capable, or there's not enough sustainable energy used for the data centers actually.
Yes.
So you can
Yeah.
I'm very I make the story very easy.
If you put it bluntly, the overall energy in the Netherlands, still roughly 50% of that, with the latest numbers I saw, is actually generated based on gas and coal at the moment. Whereas in Norway, the numbers are completely different. They have relatively a lot more green energy sources.
Okay. Wow. So that is the whole part of data center, how they build, how they use it, how they use their energy. But that's one thing. That's What can you do as Ab Ovo to take a look into this and say, okay, we want to be more sustainable. What can you do something about the data centers or with the data centers?
Well, So there's looking at this entire picture, that carbon is created by manufacturing the data centers, but also basically, as in real estate, location.
Okay.
It depends where the data center is set. That you can lower the carbon emissions. So you can do the same thing, choosing the right data center, choosing the right size of the data center, and also choosing when to replace IT, whether it's a data center, but also more the physical devices like your laptops, do it 5 years or do it in 6 years. That's actually those changes. That's called operational efficiency.
Okay.
And by making the right changes or the right choices in operational efficiency, you can cut carbon emissions tenfold. So 10-fold. So by making all the right choices, you can reduce your carbon emission by a factor of 10.
And that sounds already quite a lot. But when you think of that, when you're like a company of 500 people, it's that 500 times that 10.
Yeah.
So that's quite
it's quite a lot. And a lot of companies are already looking into this, demanding also the carbon reporting from those data centers. And they're trying to run operational efficient IT departments. But we as Ab Ovo actually took a step back and tried to look further than that. Because in the end, all those data centers, they only exist for one reason. The only reason a data center exists is because you have software that you want to run somewhere.
Yeah, of course.
If no one would build or deploy software, then there wouldn't be a market for data centers. So the only reason we're emitting carbon in those data centers is because someone is running software in it. And actually, if you look into software, you can also create software that takes a lot of energy to do a task, or do the same task with less energy.
Okay. So more efficient software is actually really not using as many power to generate its purpose.
Yeah. So there have been studies that even choosing a language, so software can be written in different languages.
Yes.
And even choosing a language, the choice for the language in itself, can already have an impact on the amount of energy needed to run functions on a server. So we as Ab Ovo were choosing to generate all our applications with C++ code. We have the Ecologic development platform, and we generate optimized C++ code. And the reason we're choosing that language for writing code is because it's amongst the top 3 most efficient coding languages that are available.
And efficient as in you go from step A to B, it takes the least steps, or it's just you can make your code very small, compact.
Yeah, it requires the least amount of effort in that sense of a computer chip to do the task it's been asked to do.
Wow. Okay.
And actually, the reason for that is C++ is a fairly old language. It originated a long time ago. And in the past, computer engineers also had an issue. They were asked to do a lot of new software, a lot of new computations, but computer chips or computers in themselves, they weren't widely as available as they are now.
Of course.
And they were very expensive. Hardware was very expensive.
Yeah.
So what they did is they created a language to very efficiently make use of the scarcely available hardware as efficient as possible.
The more you can put on one chip or make one chip work on, that's efficient.
The less computers you need. But over time, the hardware in itself became cheaper, and labor became more and more expensive. So what happened is that instead of optimizing for using as little hardware as possible, in the world of computing, we started optimizing our languages to have as high a production output as possible. So we were starting to make, and I say we, of course, I wasn't part of that trend, but
IT in general, IT developers in general,
we developed new generations of languages.
Okay.
And each generation of language made it easier for a human to read the language and understand what the computer program is doing. So you can write a function a lot faster, basically. You can train new people a lot faster because the language is more intuitive. But that human readable language isn't readable by a computer chip. A computer chip is fairly stupid. It thinks in ones and zeros.
Okay.
So you need an additional translation layer, basically, between that readable language and that ones and zero before the computer chip can do something.
Yes.
And that means that the chip has to work harder to perform the task you're asking of it.
Okay.
And what we saw is that people were scarce. We needed to have more production per developer.
Yeah.
So we used simpler languages and just bought more chips. That was a very sensible thing to do. But now we're going into this world where, well, actually, now chips are also getting scarce again.
Scarce. Yeah,
so,
more expensive. Yeah.
So there's also that aspect. But we're also looking more into, do we have enough energy available, or do we want to keep producing new hardware to run our task? Or should we think about making sure that that chip is doing it in the most efficient way possible? And that's when you can return to those older languages, which were far closer,
easier, and
needed less translation for the chip to perform its tasks.
Okay.
And that's why C++ is a lot more efficient than modern languages like Python or TypeScript, which are very popular at the moment.
Yeah.
There's actually a factor 70 to 80 in energy efficiency between C++ and Python. So meaning that if you have the same code, the same software, everything is exactly the same except the language.
Okay.
That same piece of software would require 70 times more energy to run its task.
But it's just that you need more people because you need more software, or you need all is digitized. So you want to use people that are less needed to be schooled. So it's easier for them to write a piece of software.
Yeah.
But on the other side, it's actually
it
easygoing requires a lot of extra energy.
And And in a world where energy supply and data center supplies are endless, that's fine. But we're now thinking about actually the impact of that with sustainable IT. We're starting to think about what does that mean for our carbon emissions. And now we can take a step back and think, actually, we're doing it wrong, and we need to code more efficiently. And that's what we're doing with the ecologic platform. So we're creating that C++ code. And actually by doing that, just by picking the language, you can already, improve a lot. But then there's also, even with a very good language, you can write good and bad stuff.
Yeah, of course. Yeah,
Of
that's
course.
also, yeah.
So there are design principles on how to write good, efficient code. And if you apply all of those, then everything combined, that can actually cut carbon 100-fold.
Wow.
So that's software efficiency. So we have, on the one hand, operational efficiency. Where are we putting our data centers? How long are we using our laptops? But we, on the software side, the code efficiency, that's, do you use the right language? Do you optimize for efficient code in itself? And that can cut carbons 100-fold.
That's incredible.
And if you combine both
Yeah,
tactics,
that's the next question. Yeah. And when you
what if you apply both?
efficient
Well,
software,
then and that's if you make a fairly simple calculation, that's 100 times 10. So you can cut your carbon emissions 1,000-fold by both applying operational efficiency and combining it with code efficiency.
And the crazy thing is, because energy is this expensive in these times, when you can take it 1,000 times back, you almost should ask yourself, why don't you? Why don't call Ab Ovo and try to efficiency to make it efficiency and make it more efficient to use a right and use your data centers.
Yeah, so I would obviously call out to anyone to call us and help you with your solutions. But as I pointed out in the beginning, one of the reasons IT shifted away from those languages like C++ is because normally it's rather labor intensive to write applications in that code, because it's fairly complex. Getting the right skilled people to write those codes,
of course,
are fairly hard. But that's actually also something we solved at Ab Ovo.
Okay.
Because, even though our applications are generated in C++ with code optimized for code efficiency and therefore optimized for lower carbon emissions, that is done by our factory. But our factory generates that code based on a platform-independent model we input in our development platform. So our developers, they actually have the benefit of both worlds. So when building an application, they can use those next generation languages to explain the business logic. So it doesn't require those very hard language skills of C++.
The learning curve,
the learning curve is a lot lower. But by the time we deliver it to your customer, you have the efficiency and the speed of C++ applications.
So actually, you translate the newer languages to the C++.
Yeah. So we have the factory layer in between, which translates the business applications into efficient C++.
Wow.
And in that process, that's where we embed our green IT coding principles.
Yeah, of course.
So during the translation, we always apply the latest known green IT principles for efficient code writing.
And is there a number that you can show, or how much efficiency did you get by the customers, or is there any number now that you can speak of?
Yes, I have to look it up.
Of course, no. Yeah, but that would I can say to everybody, hey, call Ab Ovo. But when, of course, there is a number that you can say, hey, for our customers, we cut the energy efficiency to 40% than they were used to be, or even
so. What we also build into our platform is measurements. So we have the capability to measure, not on a system level, but on a function level, what the impact of that particular function is.
Okay, so not the system, like
So we don't take the complete system, but every single click on a button, we measure. Every interface running in the background, we measure the impact. And we do that by measuring the number of CPU cycles, the memory use, CPU usage in total, CPU time. But also collecting metadata about the computer chip it's been run on, that particular process. And by doing that, we can calculate the energy needed to run a single process. So for every click of a button, we can say, well, this click of a button took 0.000 something gram of CO2.
Okay.
But if you add that all up, that still adds to a bigger number. And what we're mostly interested in is doing those measurements every once in a while, looking at the system, and then see where can we improve. So when we deliver a new version, we can also spot, hey, these are the areas where we can improve or where we have to change our code or make it even more green.
You can have like a heat map, and where can you bring the heat down?
Yeah. Exactly. So what is being run a lot of times per day and has relatively high carbon emissions compared to the rest. Well, if we improve that, so we can do the analysis. But sometimes it's not even changing the code. Sometimes it's changing user behavior or configuration of the system.
This is with AI, like when somebody asks, "Oh, thank you."
Yeah,
that AI, the data center has to start over again to deliver you an answer. When you say thank you, they say, "Oh, no thanks." That no thanks has the same amount of energy usage as the whole thing you did before.
Yeah, so that's user behavior. So cutting down the global AI energy usage is just by having people being impolite to ChatGPT.
Exactly,
you can actually save a lot of CO2.
It's not going to get you in the end of of times. when robots taking over.
It is a safety rail. So if the Terminator ever happens, at least you can say, "But I was always friendly to you."
That's true.
No, but coming back to our report. So what we do is we can also see how much a function is being called, and in our system we have a lot of interfaces coming in our business applications,
of course,
and you can configure that in different ways. So we leave it up to the customer to configure it in the way that suits their business processes. But looking at the reporting, we can also see just an example. You have configured it to check every 10 seconds if there's a new message, but we see that in general a new message comes in once every minute. So that means you're doing something 6 times, where on average only 1 in 6 time, you actually have to do something.
Wow. Yeah.
And even though it's a very little function, very little amount of energy needed to check if there's a new message, what if you just turn it off for those, or increase it to once per minute? And those type of configuration changes, those can actually have a lot of impact. So we have one example with one of our customers where, based on the analysis, we had a function which ran 86,000 times per day.
86,000, okay.
86,000 times per day. And we configured that in a different way because it wasn't needed based on their business processes. And by doing that on that particular function, so not the system as a whole, but on that particular function, we actually reduced the CPU usage 90%.
Wow.
So if you, in the end, energy is CPU being run, therefore it needs energy. So for that particular function, we reduced it 90% the carbon emissions.
Yeah, when in a lot of parts of the company, it's 90% of all those places or all those
function
offices.
Yeah. So that idea of turning things off.
Wow.
And sometimes the best things are just open doors. They're simple as possible, but they're the best way of innovating. And that idea of turning things off is called light switch ops.
Of course, yeah.
Because at home, when I go out, I turn off my lights.
Yeah.
Why? Because I'm not in. I don't need light, and it saves energy, especially with the current prices.
Absolutely.
But in IT, strangely enough, you might turn off your laptop, or you just slam the lid close. I think a lot of people slam the lid close. Fewer people actually turn it off.
Yeah.
But that's your laptop. Well, what about the data server that's running? What about your financial bookkeeping system that's running?
True.
A few people are actually doing their bookkeeping between 6 o'clock in the evening and 9 o'clock the next morning.
No.
But the system is always on.
That's true.
We don't, in IT, we don't turn things off.
Yeah, because also the when you slam your laptop, you close your laptop, things are still running in the background.
Yeah.
It's also okay. Of course, you're not clicking, or but every notification that you set on, that you put on.
There will always be some background processes still running on your laptop, but
the battery empties.
Yeah.
The battery empties, so it is running.
Yeah, but especially if you look at the business software, which is typically run on data servers, which are either on premise in a building or the big cloud servers. Typically, those servers never go down. They don't turn them off. Everyone goes home for the weekend. Everyone goes home for the day.
Yeah.
But you don't turn off a server. And that's another thing we also build into our application. Is the reason we don't turn those things off is, well, to be frank, most IT managers are scared. Will run again if I turn it on.
Oh, that's true. Yeah.
Can the application actually handle a quick termination, and can it be switched on the next day, and will everything run smoothly? So we also invested a lot in making this turning off your application to make that smoothly. So to make sure that all the processes are queued, and the moment you turn the application on again, it knows what it was doing, and it would just pick up what it was doing in the right order.
Okay.
And because we did that, internally we have a lot of different customers, a lot of different projects, and we have development and test environments and acceptance environments.
Of course.
So basically it's our number of customers times 6. Those are the environments that are running. And 9 out of 10 times you're not working on a particular environment.
No.
But it does keep running. So one of the things we actually did, and that was as a result of the reporting we also did on our own applications, is, hey, why do we keep things running by default and only turn it off when someone thinks about it? We move that mindset around. Now we turn everything off by default. So every night or every evening, we turn everything off.
Yep.
Unless someone has specifically asked, can you keep this application running for me because I'm working late, I keep working on it, or whatever. And that in itself, we have seen that reduced a lot of processing.
Yeah, of course.
And because we have less environments running at the same time all day long, we also actually didn't need to buy a new server because our server was getting full.
But not when you're,
But when
by useless information or by useless usage, actually. Yeah.
By zombie workloads.
Oh, wow.
Basically, because that's a term. And it wasn't coined by me. It was coined by, I think her name was Holly Molly from Red Hat.
Yeah.
So the light switch ops and the zombie workload, that was inspired completely by her. But that's another way, which is something very simple, turning applications off. It also reduces the amount of servers you need to buy.
But in the early days, like 10 years ago, the problem also was when you turned something off and you turned it on again, because the chips were a lot slower. It took a long time to start up. We always say, I'm turning on my computer now. I'm going to grab a cup of coffee and I will be back and it will be on. But the great thing now is from the efficiency of chips and the laptops or all the hardware is so fast. It doesn't take time to start up again.
Indeed.
So it doesn't. Indeed. So it's old behavior.
It's old behavior
Yeah.
where we're imposing still on our applications and the way we think about applications. But it's not, in most of the cases, if your application is built in the right way, it's not needed to have it running.
No.
You don't need it. And this also overall, if you multiply that by the number of application or number of zombie loads that are running worldwide in itself.
That's crazy. That's a crazy amount of number. Yeah, that's a crazy amount. Wow.
So
this is an eye opener for me. For me at least. So I think a lot of people who are listening or view this podcast, I don't think a lot of people thought about switching the light off in their laptop or in their data center. So that's a great way thinking forward.
Yeah. So I hope if anything, you can forget most of it. But if you remember the conclusion, then I think any podcast is successful, right?
Yeah.
So basically, it's all about architecture, design, and code.
Yeah.
And if you want to cut your carbon emissions from IT perspective, think about how do I make sure that that embodied carbon that comes from manufacturing, how do I spread that out over as many years as possible? So maybe use a laptop 1 year longer than you were planning to do. Location.
Yep.
Where are you putting your data centers? But also efficiency of the code you're running in itself. So that's
the conclusion.
That's the
for
conclusion
today. Thank you very much.
Yes,
Have
no
a great
problem.
one. Bye.